Hi viewers, welcome back to the fifth lecture of this online series of lectures on Introduction to Category Theory. So we were up with the proof of this first lemma of the universal property of products. So as we were saying that to provide a function from A to X cross Y denoted by L is equivalent to providing a unique element LA in this product for each A in this big A. We need such a function. We need such a function for which the left and the right triangles, so this was the diagram X cross Y, projecting onto the second factor Y, and here on the right we have the projection from onto the first factor X, and from A we have two arrows, well, F and G, and we have this dotted arrow that we want to find or we want to define. We need such a function for which the left triangles and the right triangles are separately commuting. For which the left and the right triangles above there commute separately. Okay, that is what we want. So by the commutativity of the left triangle we have, that is I1 composed with L, I1 composed with L, we denote this dotted arrow with L, I1 composed with L should be equal to F, and Phi2 composed with L should be equal to G from the right hand triangle. Okay? So now observe that an element of this product is an ordered pair of the form X comma Y. Okay? So what we want by this cumulative diagram, in other words, using this equality of two functions, we just add both the sides here of this equality on a certain element A, say A of this set big A. So therefore we want I1 composed with L acting on A should be equal to F of A, right? This is what we want in order for the diagram to come in order for the left hand triangle to be more precise. So we want I1, what is LA? LA is by assumption X comma Y. I1 X comma Y is equal to F of A. This is what we want. In other words, so I1 X comma Y is precisely X with because it's the projection onto the first factor. So we want x equal to f of a. Using the second equality of two functions here, so that the right hand triangle commutes, we have particle composed with L acting on A is precisely equal to GA. From this equality of functions, we act both the functions on an element of bit A. So from which we see that I2 acting on LA is an ordered pair given by x comma y is equal to GA, from which we get it's the projection onto the second factor, so that we have y equal to GA. So what did we get finally? Therefore, it is necessary and sufficient to define. So, because we want LA to be equal to x comma y, and we need x to be equal to f of A and y to be g of A. Alright, so it is necessary and sufficient to define f cross GA, which is precisely our L, the unit function that we are looking for, should be nothing but an ordered pair in x cross y given by fa comma g. For all A. So we have proven the existence and uniqueness of the function f cross g. Okay, so now let's get back to the breed of dots example that we had earlier to define, to explain the product of two sets. So back to the example of breed of dogs. So back to the example of breed of dogs. Okay. All right. So let me draw the table representing containing all the elements of x cross y again. Okay. For some reason, I will try to use for the reason of clarity, I need three colors here. Okay. So let me separate certain elements from this set in different colors for reasons to be explained later. So 1, I'll explain. Let me make the table first. I will explain it later. 2, club. 3, club. 4, club. 5, club. So 5, club I put in different color. 5, club, and then write in red color. 5, club. 5, club. And then again I have black color, 6, club. So I'm going to put dots here representing these ordered pairs. Black dots, all black dots. The fifth one are a red dot, and the sixth one is again a black dot. also from below. Now the second will be 1 comma diamond with a black dot. Then you have to have 2 comma diamond in blue with a blue dot. And 3 comma diamond with a black dot again. 4 comma diamond with a black dot again. Then I have 5 comma diamond with a black dot, and I have 6 comma diamond again with a black dot. Then I have the third row. 1 comma hertz. I have 2 comma hertz. I have 3 comma hertz. Then I have 4 comma hertz in green. 4 comma hertz in green. 4 comma hertz in green with a green dot. And then I have 5 comma hertz. And then I have 6 comma hertz. These are all black dots. The final row is everything is black on the final row. 1 comma space, 2 comma space. We have 3 comma space, 4 comma space, 5 comma space, and I have 6 comma space. So everything is black. So why they are in different colors will be clear in a minute. Okay, this is X cross Y. Okay, now I have this set Y here that I drew earlier with 4 elements. So the 4 colors in a suit of curve. So I'm gonna draw the first one in red. The first one is a club with a red dot, and a diamond with a blue dot, a diamond with a blue dot corresponding to the second row here of the table on the left, and a green dot for the earth. And a black dot for the space. Okay. And this map is pi 2, projection onto the second factor. Now we have this pi 1 map, which is the projection onto the first factor, which projects the product X cross Y onto the set, the given set X, which consists of 6 elements. One is given by the black dot, and then 2 is given by the the blue dot, okay, 2 with the blue dot, with the blue dot, and then 3 with the black dot again. 3 with the black dot again, and 4 with the green dot. 4 with the green dot. 4 with the green dot. 5 with the red dot. 5 with the red dot. And finally 6 with the black dot again. 6 with the black dot. Okay. And what was our set? So the set A for the universal property is going to be the set going to be the set with 3 elements. 3 elements A with the blue dot, A with the blue dot, and then B with the A with the green dot, sorry. Then B with the blue dot, B with the blue dot, and C with red color. So we have C in red. Okay. So from A to X, so this is X cross Y, this is X, this is Y, this is A, and from A to X, in the universal property, the function that we had is F, and from A to Y was the function G. Okay? Alright. So here you see that you can see the function using these colors from this picture. So you see that, just consider the function from A to X. So A is mapped to 4. So this coloring thing means that f of A is equal to 4. And what is f of B? F of B is equal to 2 because B is in blue color, so is 2. So 1 is the image of the other. 2 is the image of B under the function f. And what is FC? FC is equal to 5. Right. So similarly, from here, G of A is hearts here, G of B is diamond here, and G of C is club here. Alright? So we wanted a unique function from A to X cross Y like this broken arrow in the diagram of the for the universal property, the commutative diagram, you see that A is under this coloring thing mapped to. So how did we define it? Remember that we had defined this unique morphism as f cross G acting on an element of A should give us f of A comma G of A. Okay? So what should be, for this example, what should be f cross G acting on A? it should be f of a comma g of a. What is f of a? We have seen that f of a is 4, and what is g of a? G of a is hertz. So f cross g acting on a should be 4 comma hertz. Where is 4 comma hertz? 4 comma hertz is here. So that is given in green color because A is of green color. Okay. For what is f cross g b? It should be fb comma gb. And what is fb? fb is 2 and gb is what? gb is diamonds. So since b is in blue, 2 comma diamond should be in blue too, that we have done here, and so forth, so forth. So we'll come back after a break for the third segment. Thank you for your